video, I want to really discuss logarithms, understand what they are, what they can be used for, because this is a very, very big topic in maths. So, first of all, before we get stuck right in defining a log, let's just look at some numbers and get a feel for why logarithms may exist. So, if I were to give you the following equation, 5 to the power of something is equal to 25, you would just spot, oh, I recognise that 5 to the power of 2 is 25. Similarly, 5 to the power of something is 125. Hopefully we can recognise that I need to multiply 5 by itself 3 times to get 125, so that's 3. If I were to give you 2 to the power of something is equal to 8, we can recognise it's 3. But what if I were to ask you the following question? 2 to the power of what is 9? Okay. Now 9 is not an exact power of 2. We have 2, 2 squared is 4, 2 cubed is 8. So if I know 2 cubed is 8, then obviously if I want to get the result of 9, then obviously it has to be slightly higher than 3. But then when you go to 2 to the power of 4, you're at 16. So it's obviously close to 3, but we know what that figure is. We could use trial and improvement to get an estimate for that value, but we want to do a bit better than that. And that's where logarithms come in. Logarithms are used to find that power for a specific base being equivalent to a number. So let's have a look. Right, so before we have a look, let me just give you some other introductory work that I think is quite helpful. If I give you the number 5, and we perform the operation multiplication by 2, obviously we know that's 10. But the inverse operation of multiplying by 2, in other words, what operation would take me back from 10 to 5, is obviously division by 2. Now, 8, different number this time. If you add 3, you get 11. And then you subtract 3, that's the reverse operation. Another number, 6. This time what I'm going to do, you're familiar with this button on the calculator, is I'm going to square. I'm going to square 6. We get 36. How do we get back from 36 to 6? We do the reverse operation, which is square root. And now we come onto the logarithm. So let's deal with the number 3. Now, unlike the previous examples, where we took the number, we directly did something with the number. We took 5 and we multiplied by 2. We took 8 and we added 3. We took 6 and we squared it. What I'm going to do with the 3 is I'm going to stick it up as a power of another number. So what I'm going to do is I'm going to take 3 and I'm going to make that the power of the base of 2. Now, I just chose 2 as a random base. Okay, but we could choose any base. So if I take 3 and I make it the power of a base of 2, we know we get 8. But how do we get back from 8 to 3? That's not obvious. All these other reverse operations I just wrote down in a second, because they're naturally obvious. This is not obvious. How do I get back from the result of 8 using a base of 2 and know what that power is? It's the same question that I'm asking over here. And that's where the logarithm comes in. So what we say is as follows. If you do log base 2, because I'm looking at a base of 2, of the result of 8, you get 3. And on your calculators, you have a button that looks like this. That log button is what will allow you to do this process, to go from a result back to a number where the number is a power of a certain base. So going back to this problem over here, this now gives us the tools we need to tackle what's known as an exponential equation, a power equation. I wanted to know what power of 2 gave me 9. That's exactly this problem here. So what we say is you do log base 2 of 9. So what we're saying is that statement there means what power of 2 gives me 9. That's what we're doing. And this can be done on your calculator. So pick up your calculator, look at that button on the calculator, put in a 2 there and a 9 there, and let's see what we get. It's not going to be a nice number. It's going to be a decimal. And if we see, I remember we said it had to be close to 3, a little bit higher than 3, and it's 3.1723 significant. Now we need to be very happy when I give you a logarithmic statement to understand really what it means, not just perform it in a blind manner. So, log 525. Remember what we said. What does the logarithmic function do? For a specific base, it asks the following question. It's saying, what power of that base would give me that result? And obviously we can recognise that 5 to the power of 2 is 25. We can spot the answer. Now I wouldn't need to use the calculator to work log 525 out because the answer is obvious. We'll be using this log button on the calculator for non-obvious results. And we can now generalise to the definition of the logarithm, which is as follows. If you have a statement like this, log a b equals x, what does that mean? It means the base to this power is equivalent to that number b, because that's what the logarithm is doing. The logarithm is identifying what power of that will give me that. This is equivalent to saying a to the power of x is equal to b. We use logarithms in maths to find powers. This is the powerful tool of logarithms. It can identify a power. Most of the time in maths we're looking at the base. Quadratics is when the unknown is the base, x squared, etc. Cubics, right, same thing. Okay, a lot of the time we are using maths to find the unknown x, where x is a base or just a single variable. Now, when the unknown is a power, that's when logarithms come into play. Okay, so just as a quick exercise, now I do not want you to use the calculator. Using the definition of the logarithm and what we've understood about logarithms, I would like you to calculate what these logarithms are. And then obviously we can check later on the calculator that is indeed the correct answer. But I'd like you to have a go at these 5 questions, and then we'll talk through it. So pause the video, write these down, have a go at them, and then press play and we'll go through it. Okay, so hopefully you had time to go through those 5 questions. So let's think. Log base 2 32 is asking the question 2 to the power of what is 32? So just count the powers of 2. 2, 4, 8, 16, 32. I need to multiply 2 by itself. I need to multiply 2 by itself 5 times to get 32, and then the answer is 5. Right, log base 10 of 1,000, 10, 100, 1,000, it's 3. Now what about this? It might be useful to write that down in power form so we can understand. What does this mean? 3 to the power of what is this? So actually what I'm going to do is I'm going to rewrite that as 3 to the power of x, where I'm looking for x, is 1 over 27. Well, what we realise is 27 is 3 cubed. Okay, 27, that's not a coincidence, that's an exact power of 3. That's 1 over 3 cubed. And we know 1 over something is a negative exponent. It's a negative power. So I can write that as 3 to the power of minus 3. So 3 to the power of x is 3 to the power of minus 3. Well, that's my answer. I can see minus 3 matches up with that x. So the answer is minus 3. You are allowed to get a negative number as a result for a logarithm because we're allowed to have a negative power. All a logarithm is doing is telling you what a specific power is for a specific base and a given result. These two results here are very important. Log base 5 of 1. What power of 5 gives me 1? Well, you may recall from GCSE that anything to the power of 0 is 1. So, the answer to this is 0. And not only is it 0 for this specific example, but log to any base of 1 is 0. Because anything to the power of 0 is 1. So that could be 6, 7, 8. Log for any base of 1 will always give me 0. That's a very important result. And this one here, log base 10 of 10. Right, the base and the result could be the same. What does this really ask? 10 to the power of what is 10? In other words, a number to what power is itself? Well, that's got to be 1, hasn't it? 10 to the power of 1 is 10. Now, those last two results we had are very important. I'd like you to get them down. We said that log for any base of 1 is always 0. That's a very important result. It comes up a lot in the work we'll do on logarithms, that if ever you have log of 1 for any base, that's actually just 0. Also, log for any base of itself, a could be any number, could be a different letter, we said that was 1. A couple of other important results are as follows. Log base a of a cubed. Can you pause the video? Do not use your calculator. It doesn't really help to use your calculator because a is not a number. And think what that result would be. So, it's all about thinking logically and using the definition, having a good understanding of the definition. What does this really ask? What power of a gives me a cubed? Well, the answer's there. A to the what gives me a cubed? Well, it's told me, it's there. It's 3. Because if I raise a to the power of 3, I get a cubed. Now what I'd like you to do is I'm going to allow you to use your calculator. Using your calculator, which is using specifically this button on your calculator, I would like you to make the base 6, and I would like you to fill in this box as minus 1. Put that into your calculator and see what happens. Right. You should get a maths error. The calculator produces an error. Now, a lot of the time we get errors on the calculator. Sometimes it's because we input things incorrectly. That's a syntax error. But this is actually a maths error. A maths error means there's a problem with doing that. And whenever you get a maths error on the calculator, I think it's always important to understand why it's happening. It helps your own understanding. Why would log base 6 of minus 1 give a maths error? Well, let's think. You are instructing the calculator to perform 6 to the power of what is minus 1. You're basically saying 6 to the power of x is minus 1. What is x? Well, anything to the power of something cannot produce a negative result. You may recall from our work using the graphs of exponential functions, even done back at GCSE, that an exponential graph looks like this. Y is a to the power of x for a value that is bigger than 1, goes through point 1 here. The y values are always positive. You cannot raise a number to a power and get a negative result. That's why the calculator gives you a maths error. So never attempt to log a negative number for any base. It cannot be done. If you arrive at a situation where you have to log a negative number, something has gone wrong.